Hello, and welcome to another session of the Secure Developer. I'm so excited to be here. For those of you who don't know who we are, we're an inclusive community that educates and enables developers in application security. Today, I am joined by Philippe De Ryck, and he's going to be talking about Angular and the OWASP top 10. But before we get started, for those of you who don't know me, my name is Sam, and I'm the community manager here. So if you have any questions, any topic ideas, feedback, please ping me. You can ping me on Twitter, on our Slack channel, or get hold of us on the website, thesecuredeveloper.com. Slack's actually the best place to interact with Philippe today. So if you have any questions about his session, please jump onto the website, click on Slack, and join the live sessions channel. And you can ask questions directly to him, just like a meetup. If you're watching the session after we've gone live, please feel free to still jump into the channel and ask questions. Philippe has a member there, and so he can answer your question as they come through. The last thing, just to remind you on, is there's a little cog at the bottom right-hand corner of your screen. If you put your resolution up to maximum, that's the best way to view today's session. But other than that, that's enough from me. I'm going to hand over to Felipe, and I hope you enjoy the session. So hi, Philippe, sorry, welcome to the Secure Developer.
Hi, thank you for the very kind introduction. And hi to everyone listening in now or later. So let's get started by sharing the screen here. So if everything's good, you should see the title slide, and we are all ready to go. All right. So today, let's hide this. And today, we're going to talk about Angular and the OWASP top 10. So Sam has told me that apparently there have been a couple of questions about security in Angular and in JavaScript. And I actually picked a few topics from the OWASP top 10 to talk about here today. Before we start, maybe a small word about the OWASP top 10. So the OWASP top 10 is a top 10 of the most dangerous web security vulnerabilities that are present in web applications. And it's built by OWASP. And OWASP is this non-profit organization with the single goal of improving the current state of security. It started out as web application security, but they broadened their scope into essentially software security, mobile security, container security, and all of these things. And it's mostly a volunteer organization. So a lot of people are involved, volunteering their expertise, their knowledge, and essentially trying to build useful resources and tools and whatnot for the community. And one of their most profound documents is the OWASP top 10, which is something they release every couple of years. And essentially, it's the best awareness document available out there. Almost everybody involved with web security is somewhat familiar with the OWASP top 10. And here you can see that the top 10 from 2017, which is the most recent edition. And you can see, if you know a bit about security, you can see some familiar things like injection, that points to something like SQL injection, command injection, the traditional security vulnerabilities. These are very, very dangerous. They are definitely listed at number 1. Of course, you have a few other things as well. I'm not going to go over the entire list. But if you look deeper into this document, if you find that online, you'll be able to see there's like a one-pager on every one of these vulnerabilities. Explains like what is the problem, how dangerous is it, how is it exploited, and how can you find it in your application, and most importantly, how can you fix that in your application. And that's essentially what the top 10 is about. What I'm going to talk about today is how this applies to Angular applications. You can imagine that Angular applications usually don't really suffer from SQL injection. That's going to be a backend problem, but not necessarily a front-end problem. So what I actually want to talk about before we dive into the issues is how Angular applications are different, especially from traditional web applications. So in a traditional web application, you used to have everything on a server side. So the server gets a request, does some processing, generates a page, and sends it back to the browser, and that's about it. In an Angular environment, these things kind of change, because now you no longer have server-side. Well, you still have server-side processing, but now you have an actual application running in the front end. It's not just a web page anymore. So what you see here is the bootstrapping phase, where Angular is actually being loaded from a server, a static web server, and it will essentially be loaded into the browser. These are traditional browser-based requests. You navigate to a website, it's going to load some HTML, JavaScript, and bootstrap the Angular application. Once that is done, typically an Angular application is going to communicate with an API. So there is still a backend, but it's kind of separated because the API no longer serves pages. It simply usually returns JSON data, but can return anything you kind of want. So this is under your control. You build the client, you build the API, and you can choose whatever format you want to choose there. But JSON is actually very common. And this split in deployment is something that we don't see in, or see less often in traditional applications, but we see that in all modern JavaScript applications. So you have this with Angular, you have this with React, Vue, and Ember, and all the other ones as well. So this is definitely a big important difference, and I'm gonna come back to this slide a few times throughout the presentation to show you why this actually matters and why certain things have changed significantly. One of the important changes, for example, is security headers. Security headers are a mechanism to tell the browser to behave in certain ways, and this used to be a per page setting for your application or a per domain setting. You simply set it on the server and you're done. Now, these kind of things, these headers will be applied on the Angular application itself. It's called a single page application because you actually load a single page which runs JavaScript, and that JavaScript will embody your entire application. So we'll see a few examples of why that matters later in the talk here. So that's essentially the deployment scene, the setup scene, to allow us to talk about the OWASP top 10. So we have here the overview of the top 10 as we had before. This is just a general way of looking at things, mainly in a generic web application environment. So injection, yes, is still #1, not necessarily for Angular, but it's going to be for traditional applications and also for the APIs backing Angular application, of course. In an Angular application, I've taken the liberty to reorder the top 5 a bit, the top 10 a bit, and I think that the top 5 you see on the left here actually matter quite a bit in Angular applications. So I've put one on top, which is using components with known vulnerabilities. I think that is one of the major problems we face today, and it's going to be a significant problem in the future as well. And there's a couple of other things. I'm going to talk about 3 today. We only have an hour, and there's so much to say about all of these things. So instead of giving you like one slide on every topic, I'm going to actually try to go into a bit of detail on these 3 main topics. I'm going to start with sensitive data exposure, which is in my personal top 10 here, or top 5, the least important. So I'm going to build up throughout the talk to make sure everybody sticks around until the end to make sure you have gotten all the information. So let's start there. Sensitive data exposure is essentially an item where you might expose sensitive data to people that are not supposed to see it. And the primary problem in web applications there is transport, is the use of HTTPS, which is really, really, really important. So I promise to come back to this picture and to talk about how this actually matters in Angular applications. So for HTTPS, this means that you're going to apply HTTPS on the channel where you load the Angular application. Obviously, you want to load your HTML and JavaScript in a secure way, so you're going to need some HTTPS there. And you're also going to need some HTTPS in the backend on the API. So let's talk about HTTPS for a bit. One of the things you should know upfront is that HTTPS has gotten a lot better than it used to be. So many people will say that HTTPS is slow, expensive, and nightmare to configure, and so on. Well, I have good news. Today we have Let's Encrypt, and Let's Encrypt is a free, automated, and open CA. And essentially what they do is they offer you free certificates you can easily use to deploy any kinds of application. They have automated the whole process, and they have essentially taken the pain of managing certificates completely away. One of the awesome things is they have a tool you can install called certbot. And once you request a certificate with the certbot, what it actually does is it installs an automatic cron job to renew that certificate when it's about to expire. And it does this, checks this every week, so you no longer have to worry about all of that yourself. There's some rumors online that Let's Encrypt is free, so you get what you pay for, and it's crap, and this and that. And honestly, these are usually or mostly non-relevant. So Let's Encrypt is really good. What they offer is absolutely awesome. It is backed by a non-profit, which is again backed by a lot of commercial companies, and it's definitely highly recommended to use, and I personally use it myself as well. So that's the basics about HTTPS. Let's talk about how to use that in your application. If you want to load your application, or if a user wants to load your application, they're typically not going to go to the HTTPS version. They're typically not going to type https://restograde.com or whatever application you're building. No, a user is going to type restograde.com or facebook.com or twitter.com or whatever. And when that happens, the browser actually sends an HTTP request. So the browser does not use HTTPS by default, because if it doesn't work, then it's going to create very nasty errors. So the browser cannot rely or expect that to happen from the beginning. So the first request is going to be HTTP, which is unprotected, unsecure, and definitely dangerous if you send that on the network. So what the server needs to do, especially the front-end server here, the server needs to send a redirect. And the server is going to send you the 301, which essentially means this resource has moved permanently to a new location. And it's going to give you a new URL, which is essentially the old URL starting with HTTPS instead of HTTP. And that is something that every web server that is using or deploying HTTPS today has to do to ensure that scenarios like this work in the browser, to ensure that if you type a domain name, that it actually resolves into the HTTPS page eventually just by taking these additional steps. And that's what's going on here. This is, if you remember the image from before, this is what you need to do on the server serving the HTML and JavaScript from your Angular application. However, if you are also serving APIs somewhere else, there the story becomes a bit different, because when you have an API, there's no redirect process going on. There's nobody going to access your API, in this case, by typing api.prestway.com, because your application is going to access that API. When the application accesses that API, it's going to use the API endpoint that you as a developer have specified. So essentially, what you can do here is you can tell the browser to use HTTPS upfront, and essentially the browser will do that, and there will be no redirect. So one of the takeaways you can get away from this slide, I'm going to show you an overview later on as well, is that the front-facing server, the server handling web requests, needs that redirect. That's very, very crucial to ensure everybody ends up at the HTTPS version. But your APIs, if they're deployed on a different host, if they're deployed on a different host name, so to say, they can just support HTTPS, and there's no need to support HTTP and the whole redirect mechanism. And that's already a first difference that we see in Angular-based or API-backed applications compared to traditional web applications. Of course, deploying HTTPS is kind of well known. It's something that everybody is should be aware that this is actually highly recommended and mandatory for modern web applications. However, deploying HTTPS alone is not going to get you there. So in this article from 2016, it states that 95% of HTTPS servers are still vulnerable to man-in-the-middle attacks. And they're actually kind of trivial. There's tools available to easily execute those attacks. Of course, 2016, that's like ages ago in internet time. Today, or at least in the second quarter of 2019, that number was still 78%. So imagine 78% of the servers out there offering HTTPS, doing actually a good job in offering HTTPS, haven't gone the extra mile of making sure that their HTTPS deployment is fully secure. And that's kind of a problem. And to fix that, you need to add additional security measures to your HTTPS deployment. And these additional security measures matter to counter one specific type of attack, which is kind of dangerous, and that's called SSL stripping. And I have a small scenario of what SSL stripping actually looks like. So in an SSL stripping attack, the attacker is trying to attack, or is going to attack on the network level. So imagine if you travel a lot, you probably visit a lot of strange Wi-Fi networks in airports or in hotels or all of those things, and you honestly have no idea what's happening on these networks. And that's kind of unfortunate, and it might be that somebody is messing with that traffic. And if that's the case, they can execute an SSL stripping attack really easily. And here's how that would work. So you have the browser on the left, and you want to contact the server on the right, which is just the web server supporting HTTPS, doing what it is supposed to do. So here's what an SSL stripping scenario looks like. Your browser is going to send that request out. You type restagway.com, and the browser is like, oh, I don't know this website, but hey, let's see where this goes. And it sends out that initial HTTP request we talked about before. The attacker is living on the network. The attacker controls the network. The attacker can easily intercept that request and decide how to handle that. And he sees like, hey, this is an HTTP request. So let's see where this takes us. And the attacker sends out a new request to see what actually happens with that request. And it's going to go to the web server, the actual web server, and that web server is going to say like, yeah, that's all fine, HTTP, whatever, but I actually need to do this HTTPS thing because, you know, this redirect mechanism, I'm actually going to apply that. I'm going to make sure that this actually works in practice. And it's going to redirect, and the attacker is going to follow that redirect, and it's going to load the HTML page following from that response. That's the page being served by the web server and expected to be seen in the browser. So what's going to happen now is the attacker is really sneaky, and he's going to take that HTML response and he's going to rewrite that. And he's going to look for every URL in that page, and he's going to rewrite every occurrence of HTTPS to HTTP. So restagway.com served over HTTPS. The attacker now changes every URL to HTTP and sends that response back to the browser. And that's essentially SSL stripping. The attacker has done is he has intercepted the initial request, fetched the page over HTTPS, and then rewrote the whole page to make sure that HTTPS was not in a loop and that the browser is serving or showing an HTTP page. So what happens now is when you submit data, think about filling out a login form, entering some personal information, whatever, everything is going to be over HTTP and the attacker is going to be in the middle, which would not be possible when HTTPS was actually used between the browser and the server, which never got to happen in this image. So of course the attacker can modify the data, can steal the data, whatever, gets a response back, rewrites the entire response again, and sends that back to the browser. And that's essentially SSL stripping. And this seems like a very complicated setup, but there's tools available called SSL strip, which you actually can simply run as a proxy, which does all of this for you. It's not the fastest code, but it actually gets the job done, and it will really easily fool people who are not actively looking for the lock icon over and over again. And even if you're looking for the lock, the tool can replace the lock icon, the theft icon, with a lock, so the lock will still be there, just in the wrong place, which might be enough to fool non-technical users. The real danger of this attack, or the problem here, is that as far as the server is concerned, everything is totally fine, because the server has a secure connection. The server saw an HTTP request, sent a redirect to HTTPS, and actually everything seems to be totally fine from that point on. And the browser is not too concerned either. The browser sent out a request and got an HTML page in return and actually shows that page. And well, the browser is not going to be thrilled with that, because today browsers will mark the site as not secure, but that's about it, because the browser doesn't complain, because the browser doesn't know that the page was supposed to be served over HTTPS. And essentially this causes a problem, and that's what the article I showed you before was about these man-in-the-middle attacks. It's not against the HTTPS protocol itself, it's against the setup phase, the redirect from HTTP to HTTPS. That's essentially what is causing the problem here, and that's why many servers are vulnerable. All right, so that's the problem, that's the setup. What's the solution? Why are only 78% of servers vulnerable? Because the other ones deploy a countermeasure called strict transport security. And strict transport security, or HTTP strict transport security, is a countermeasure where the server tells the browser, hey, I want you to remember one thing. From now on, I'm going to use HTTPS and only HTTPS, and I want you to remember that for this value of max age. So essentially, what the server is telling the browser in this instance, this is a response header on an HTTPS response. For the next year, this is 1 year in seconds. For the next year, I want you to remember that whenever you send a request to my domain, to restowate.com, that I use HTTPS. So I don't care if the user types restowate.com or even HTTP restowate.com, or you follow a link with HTTP restowate.com or whatever. I'm telling you that you should use HTTPS. And the browser will actually honor that request and will send only HTTPS traffic to restowate.com from that point on. And this policy remains valid for a year, so the browser remembers that for a year. So whenever the user goes back, if you go back next week, the browser is still going to know that, and it's going to see the new header, and it's going to remember that for another year, and so on and so on. Of course, deploying this, there's a few things to take into account, but all in all, this is a very, very straightforward mechanism to deploy, especially if you already have HTTPS enabled and only use HTTPS except for the redirect. This has zero impact on the application that's running there, because everything is already HTTPS, so why not get rid of that redirect altogether? And this is something that actually not many people know about, and a lot of people should know about, because if you and everyone deploys this mechanism, the number of vulnerable HTTPS servers would go down significantly. So I would be really thrilled if I got to update the slides in about a year, and the number would go down from 78 to like 50 or 40 or 30%. That would be absolutely amazing. So make this your personal quest to make me happy with that one thing. All right. So HTTPS, there's a lot more to be said on the topic. I'm not going to go into detail on protocols and version numbers and ciphers and all of that. For that, I'm going to refer you to this SSL server test. So this is a free tool built for Qualys, and it actually scans a live HTTPS server, and it will tell you how good you're doing. So if you get an A+, you're all good. You have everything set up correctly. If you get something less than an A+, you have some work to do to make this actually happen. You can see here that it mentions at the bottom, it says like this HTTPS HTTP strict transport security is enabled. You actually need that enabled to get an A+ score on your website. This is from my website, by the way, and I can take 0 credit for this because the hosting provider where I'm hosting the website has set up things correctly. This is not something I have done myself. But of course, if you're running your own server, this is an absolutely amazing tool to make sure everything is set up correctly. All right, brings me to a first overview slide. So I'm gonna have 3 parts in this presentation. And the first overview is that you should have HTTPS support everywhere. Even internally, essentially every connection on your application should use HTTPS. This is very, very important. There's a lot of problems if you don't, and there's a lot of things you should not assume to be safe, and the network is definitely one of them. Verify your HTTPS deployment with the SSL server test, very useful. There's also offline tools you can find to do something similar. There's, I think, SSL test.sh that does something similar, which you can run in an internal environment where there's no public internet access, for example. So that might be very useful to know as well. And then finally, deploy HSTS to ensure that all traffic is HTTPS. Read a bit about the other features of HSTS. You can make it even more strict to apply to every subdomain, things like that as well. But there's some tricky things you need to take into account there. So I don't really have time to go into detail on those topics. But again, if you have any specific questions about this, feel free to ask them at the end of the talk. I'll be around for some Q&A as well. And you can also reach out to me on public channels. I'd be happy to answer questions there as well. All right. Back to our overview image. We talked about Angular. We have our API, we have our front-end application. So let's talk about the actual content here. So the Angular application is static files. You compile your Angular app. Well, we're talking about Angular 2+ here, which is has been around long enough. So most people are actually using Angular, well, hopefully 7 or 8 by now, but essentially the new version of Angular. When you deploy Angular, you're building all of this into a static set of files. You have an HTML file, some JavaScript stuff, some CSS stuff, and you've done that on a static web server somewhere. The API is going to serve JSON data, or XML if you really hate JSON. Well, I'm not sure why, because XML is worse, but you get the idea. Have an API with some data. Remember, this is totally different from traditional web applications. And that means that in a traditional web application, you're building HTML pages on the server over and over again. And when you're putting data into those pages, the server used to have to provide cross-site scripting defenses. Now, that responsibility moves to the client, which seems very strange that the client will have to protect against cross-site scripting. Actually, this makes a lot more sense because the server has always struggled with providing proper XSS defenses because the server easily gets confused about what's going to happen. Browsers sometimes do weird things, and that causes all kinds of problematic scenarios. So now that moves to the client. And why does that move to the client? Because Angular is a static application. It's a real application running in the browser. And that means that your static files you see here on the left are actually stuff that looks like this. Well, it's going to be compiled, so it's going to be a lot less pretty, but you kind of get the idea. We're building an Angular application with templates. We're kind of defining the structure of what the pages are going to look like up front without any actual data. This is a template from the Restaurant application, one of my training applications, which shows you restaurant reviews. And you can see here, this is all code. There's no actual data in there. There's just a couple of variables like review.title, review.rating, and all of those things. Those are placeholders to put actual data in once the application is running. And where does the data come from? It comes from a JSON API in this case. So here you have a very simple JSON API, which would return one review, which is apparently not very good about this one particular restaurant. It's all fictional, so don't worry, it's not about a real restaurant. You'll be totally good if you go out to eat in Paris, I can promise that. But instead of food, let's focus on the actual mechanisms here. What's happening security-wise? What does Angular do? Well, let's filter out one specific example. If you have some Angular code where you're binding data into a template, you're putting a variable into a template at runtime, this is what it's going to look like. This is called interpolation. You have double curly braces, and essentially you put a variable name in there. And if this is your variable, you might realize that something not so good is probably about to happen. So somebody has provided you some untrusted data, a review, a title, something like that, and it says hello, and then an image tag with the source of a non-existing file. Unicorns and PNG is probably not going to be real. And then it says like, oh, by the way, if you can't find this file, you have this on error handler that I expect you to execute. It says alert 1, which is the least scary cross-site scripting attack vector you can ever find. That kind of undersells the problem, but it works really well to show you on a PowerPoint slide. In reality, the attacker is going to provide you some malicious code, and the attacker has the ability to do whatever he wants. The moment this code, this alert 1 executes, that's the moment the attacker can insert advanced payloads, and that advanced payload is going to execute in the context of the Angular application. Essentially, this means that the attacker at that point can make the application do whatever the attacker wants. Send requests, change the UI, steal credit card information, which is a very popular attack nowadays. All of that is definitely possible. So what's going to happen here if we actually execute this in an Angular application? Well, we bind that variable, the data to the variable. It's going to be put into the page, and you will see something like this. It's not going to be pretty, but the most important thing to realize here, it's not going to execute. This will not trigger the execution of the alert 1, the script code, because Angular is smarter than that. Angular actually knows that this is a kind of a dangerous pattern, putting untrusted data into the page. It knows like, whoa, this is going to result in cross-site scripting. And it automatically decides, I'm putting that stuff into an HTML context, into an HTML element. So I'm going to make sure that the browser does not see this as code, but sees this as data. So this is called strict contextual escaping in an Angular world. Angular does this automatically. Angular has done this automatically since forever. Angular 1 had the same thing. Angular 2 does it, and the other frameworks do it as well. React does it as well, and Vue does it, and Ember. They all know about these things, and they can easily apply these protections automatically, which is good because it used to be a manual effort by the developer in server-side page generation, and now Angular just does it magically by, well, it's not magic, but automatically by itself. And that is pretty cool as a developer. However, in this case, we probably don't want an image there. That's good. But if there would be some benign HTML, what if we would allow the user to use some bold or italic tags in their review? This is not going to look very pretty because it's going to show everything encoded as HTML elements, which is probably going to piss off a lot of users that actually want to use HTML tags. But again, we can use a different mechanism. So let's move on to example number 2. Here we have a way to bind this to inner HTML. So what we can do now is we can tell Angular, no, I don't encode this stuff. I actually want you to put that data as HTML inside that div. And that's what we do here with the square brackets and then inner HTML property, and we bind that variable name to that. So here's our input again. You can see that I've made the hello bold now to make sure that we can see the effect of this. And we have our same image tag of our non-existing unicorns and our on-error alert handler. And if you put this into the page, this is what's going to happen. So essentially, Angular is going to render this. You can see the hello is bold. The question mark is not because it's outside the bold tag. So the bold tags are there. You can see the image tags are there, but there's no pop-up. Where's my alert 1? And that's essentially a good thing because Angular, again, knows what you're doing. Angular is like, wait a minute. You're putting stuff inside inner HTML, and that's potentially going to execute script code. So that is really, really dangerous. And in Angular 1, Angular used to refuse to do that. Angular was like, no, I will not do that. And it will give you like a very big warning saying this is really, really, really insecure, and you should find a better way of doing that. In Angular 2, Angular says like, you know what, I know what you intend to do. I know you intend to put some data in there and you want some benign code, so that's totally fine. Let me sanitize this for you. And sanitization essentially means that Angular is going to look at that data and it's going to decide what is safe to be in there and what is not safe. And it's going to look at the bold tag. Like bold, yeah, that's totally fine. Nothing bad is going to happen. Images, well, images are pretty cool. So sometimes you actually want images. So sure, let's log images. And it's going to look at every attribute of that image tag, like SRC. Yes, I know what this thing is. So SRC with unicorns of PNG, that's totally fine. And it's going to look at on error. And it says like, whoa, I know about this on error thing. Well, I at least know it's not safe to be put into a page. So I'm going to take out that dangerous attribute and I'm going to leave everything else untouched. And that's sanitization. And that's what's happening here. And this is on by default. This means that as a developer, if you write code like this, Angular is like, I've got your back. I'm going to protect you against cross-site scripting. And that is absolutely amazing. And honestly, Angular is the only JavaScript framework that I know that does this. The other ones do not offer this out of the box. They require you to jump through some extra hoops to include a sanitizer of your own and push their data through there to make sure it's safe. And in Angular, it just happens. So brings me to a very nice overview here of what you need to do to avoid cross-site scripting in Angular. And advice number one is get out of the way. Essentially, let Angular do whatever it does, because Angular is really good at doing these things, and you should really, really allow Angular to handle these things for you. So if you do things the proper Angular way, Angular has your back. And this holds for more than simply binding to inner HTML and interpolation, because here's another example of putting a JavaScript URL inside a link. And this is a mistake in the code example, my apologies. I'm gonna fix that in the PDF that I'll put online. That's a copy-paste error of mine. But essentially, the result is correct. The yellow box, if this would have been Angular code up front, the yellow box would be the result of pushing a dangerous URL into an href attribute. So essentially what's going to happen there is that Angular will detect like, hey, I'm putting a value in an href of a link, and if you give it a JavaScript URL, that's potentially very dangerous. So what I'm going to do is I'm going to ensure that this will not happen. And again, Angular protects you. In this case, it cannot automatically fix the URL, so it's going to give you a warning like, hey, I'm refusing to put this value in that variable, and it fixes this for you. Again, Angular has your back as long as you do things the Angular way, which is binding to the square brackets href attribute. But again, I'm going to fix that slide right after the talk. So if you download the PDF later tonight, you can have the proper code snippet. Way number one, or consideration number one, get out of the way, let Angular do what it does best. There's a few more, there's 4 in total. So the second one is don't use a function or a set of functions called bypass security, trust HTML, or trust URL, or whatever. That's a really, really, really important thing. And fortunately, they call the functions bypass security. So here's what that means in practice. If you want to bind something to inner HTML, you can put it through a function called bypass security first. And if you do this, you are in trouble, because when you do this, and with our example from before, that is going to happen. So essentially, this is a very big problem. That's why it's called bypass security. It simply tells Angular, this value is safe. You can put it inside the page without having to worry about whatever's going to happen with that. So don't sanitize it, just trust me, I'm good. And this is not how you're supposed to use that function. This function is intended to be used with static data only. If you want to put a snippet of HTML directly into the page, but you have written that snippet yourself at development time, that's going to be a legitimate use case to use that function. But you should never ever use that function for anything untrusted, anything you don't know what the data actually contains, because this is going to open your application up to cross-site scripting. It's a wide open vulnerability. And the reason they call this bypass security is because in Angular 1, it was simply called trust HTML or trust SHTML, and it confused some people. Some people were confused about the fact that it actually didn't trust, didn't sanitize or do anything to the data. It simply marked it as safe. And that's why they explicitly said, let's call it bypass security. So if you see this on Stack Overflow and somebody tells you this is for security, you now know, like, if you read bypass security, you know it's not going to be for security, and you need to read documentation about what's going on. So don't use these functions on untrusted data, and again, you're good to go. Item number 3, let Angular do what it does, but make sure Angular has the ability to do that. So if you are starting to use raw DOM APIs, if you access elements directly in the browser without going through the Angular APIs, then of course Angular will not be in the mix. Angular will not be able to protect you. Same thing for third-party libraries. If you're using things like jQuery alongside Angular and you put some stuff into the page with jQuery functions instead of Angular, Angular will not be able to protect you, because Angular is simply not in the mix. So don't do that. It's a very, very important consideration again. Don't mix Angular with other things, because Angular needs to be in the loop to be able to protect you. And then a final thing is avoid giving the user control over resource URLs. And that's kind of a tricky problem. And that's one area where Angular cannot automatically protect you, because Angular does not know the intentions of your application, does not know what's going to happen. And one example, I have one slide on this last item, one example is an iframe. So what you could have is you can have an iframe with a resource that needs to be loaded. And you can define that resource in the variables. You can say like, hey, there's this variable called myFrameURL, and I'm going to put that into the source attribute, and we are good to go. And if you give that a legitimate URL, something on YouTube, maybe this live stream, I honestly don't know what video I used there, so that would be a nice surprise to see whatever that link points to. But that might be one way of doing that. Of course, if this variable is under control of the user, nothing stops the user from giving you an evil URL, like, hey, load something from evil.example.com, which can be God knows what kind of video. So the user might have used this to rickroll your victims, for example, which is not something you want. And in this case, Angular actually doesn't know where you want to load resources from. How would Angular know whether YouTube is allowed or not? Maybe you actually hate YouTube and you only want to include Vimeo links. That might be totally legitimate for your application. Who knows? So in this case, Angular cannot automatically decide whether this is safe or not, and Angular is going to give you an error. Angular is going to be like, no. I am not going to put this value in the DOM because I know this is unsafe. It's a resource URL context. I have no idea what you actually intend to do, so I'm not going to do that for you. And that's essentially what happens here. This means that if you actually need this feature, you'll have to do some work yourself. This is the only place where you have to do that if you're building Angular applications. Honestly, the best thing you can do there is not to give the user full control over this URL. There's no reason the user should specify https://youtube.be something if you know you want to include a YouTube video. So what you can do there is simply build something like this. Build a function that says get YouTube video, and it takes a string as input, and it outputs a safe resource URL which you can actually use. And what you can do here is, instead of giving the user full control over that URL, simply give him control over the identifier, and you fix everything else. So in case you want to embed stuff here, you load it from youtube.com/embed, and we simply append the input to that and make sure we can put it into the page. We also, to make sure, this is something I always recommend, better to be safe than sorry, we also run it through the sanitizer for URLs to ensure that there's no strange things happening, to ensure that the URL will not trigger the execution of JavaScript or something like that. This is, in this case, probably not necessary because you fix the host, but it never hurts to make sure Angular has the ability to protect you there as well. But this is the only piece of code you have to write to make resource URLs work. Of course, in more advanced scenarios, if you have a lot of hosts that you want to allow, you're going to have to do some URL matching. I'm not going to go into that here. It's a very complex topic, something that's often done wrong, but also there we have to take care to make all of this work. But overall, Angular is pretty good at protecting you. And Angular 2 is actually even better because it comes with a mode called AOT, which is ahead of time compilation, and ahead of time compilation compiles the templates into JavaScript code before pushing them to the browser. You do this at build time when there's no data to avoid certain subtle attacks like template injection, which are a bit too advanced to talk about here. But what you should know is you should use AOT for all your Angular applications, because not only is it more secure, it's also insanely fast as well. So this is highly recommended. And again, that's something a lot of frameworks are doing when they are being compiled before they are deployed. And that brings us to the overview here. Cross-site scripting is automatically handled by Angular, which is awesome. The only thing you need to do is to do things the Angular way. Don't use bypass security, whatever functions. Make sure your resource URLs are safe and you use ahead of time compilation. And essentially, you are good to go. And that is one of the reasons I really, really like Angular, because it does so much for you out of the box with regards to cross-site scripting. All right. For the final topic, I want to talk a bit about JavaScript. Lately, there have been some challenges with JavaScript. And we've seen these news stories about hackers attacking companies like British Airways or Ticketmaster or whatever. And these group of attackers are called MageCard, because it started with Magento and they targeted the card page where you can actually grab credit card information. And essentially their entire goal is stealing as much credit card information as possible. Why am I talking about this? Because it's actually a pretty important attack vector. Not only because there's a lot of data that can be stolen through JavaScript, but because it's really hard to defend against attacks like this, because they are quite sneaky. So in the British Airways case, the attackers added 22 lines of code to a library hosted on a server somewhere running at British Airways. These 22 lines of code were enough to steal millions of people's credit card information, which resulted in a major data breach and a big fine and all of that. And though this would have been preventable, because the code that British Airways was using was kind of static code. It hadn't been changed until since 2012, and then somebody changed in 2018, added the 24 lines of code and caused a major problem. So what could British Airways have done here? They could have applied something called sub-resource integrity. So when you load a file from an external server, from a CDN or one of your external servers, doesn't matter. But when you load it, the only thing you have is a file name. You can tell the server, I want this particular JavaScript file, but you have no idea what you're getting. You're getting whatever the server has there. Maybe it's the original file, maybe it's a file containing malware, but you honestly have no clue. And whenever it's included, it runs in your application and can do whatever it wants. In Angular, this would happen for every file you include. For example, in your index of HTML, if you pull in some additional library, some UI tool, some Bootstrap or whatever, you're pulling that in from CDN and you have no idea what you're getting. What you can do, since for a couple of years now, is you can use something called sub-resource integrity. And what it comes down to is you add an integrity attribute to the script tag. Basically, the integrity attribute contains the checksum of the file, and you tell the browser, hey browser, I actually expect a file with contents that have this checksum. So whenever the browser loads the file, if the file on the CDN being served is malicious, it will not have that checksum because you will not have used that specific checksum. So it would detect that this is not the same file and it would actually refuse to load that file. So let me put this in very concrete terms. In the British Airways case, what they could have done is they could have loaded their library with integrity attribute enabled. They would have used the checksum. Somebody broke into that server, changed that file, and the browser would then say, like, screw that, I'm not loading that file because that file has a different checksum. So this is not what I want to do. So no, I will not do that. Of course, this only really works well for static libraries, for things that don't change over time, because the moment you actually want to change something, it's going to break every application that's using the checksum. But for a file that hasn't changed in 6 years, honestly, if you use proper versioning, that should not have been a problem, and this should have been deployed to fix that issue right there. Of course, I also know that Angular applications do not use too many script inclusions anymore. This used to be kind of common in Angular 1 applications, but in Angular 2, a lot of things are added at build time. We build components and we use dependencies, and we actually base that our application on top of those. And it turns out that in a modern application, over 97% of code are dependencies. So essentially, if you're building an Angular application, you're pulling in 97% of code is going to be stuff you pull in from the internet, from basically God knows where. And this seems like a lot, like sure, 97%, but is it really, really that big? It's not that bad, right? Well, I actually ran the numbers for Angular. So what I did is I started a new Angular application using Angular CLI and GNU with a clean application. I'm going to ask you some questions like, do you want routing? Sure, I want to use style sheets. Let's use SAS for that, and off we go. And it's going to take a while. It's npm install in the background, so it's going to take a while. But after about 30 seconds, it's going to come back and tell you that it added 1,169 packages to bootstrap your simple Angular application. So now you're actually running code from 1,030 contributors. That's only people publishing npm packages. It's not actual repo contributors. So that's kind of significant. But even that doesn't tell you very much. Like 1,000 packages, sure, but how bad is that really? So if you install another npm module, you can actually count the lines of code you're pulling in. And for these Angular dependencies, for the node modules folder, from a clean Angular project, you're pulling in 2,336,000 lines of code. And to put this into context, you as a developer at this moment have written 0 lines of code, and your application is already 2 million lines of code that you're using as a dependency. And that is a major shift in how we build applications. And that is something to be really, really scared of, actually. I'm not saying it's by definition bad, because these libraries are all good. They enable you to do these things, but there's a lot of things that can go wrong when you start building applications like this. Here's only one example from 2018. A library hosted on NPM, 2 million installations, and it contains, all of a sudden, it contains a backdoor. And this story actually, well, it went really badly, because essentially what happened is there was this developer that actually built a library when he needed it. And he was like, hey, maybe other people need this as well. And he published this on NPM, and other people actually did need it and started using it. And essentially, a lot of people were really happy with the library. But this developer moved on. He started doing other things. He never used the library again. So eventually, he kind of let it fade away. Like, I'm not maintaining this actively anymore, but sure, whatever, it's still there, so people use it. And then another user comes along and asks like, hey, I'm actually really enjoying this library and I have some ideas for updates and maybe I can help maintain that library. Do you want that? Do you want my help? And this developer was like, yeah, of course, it's open source. Yes, I want help. And he gave the other user access to the source code repo. So he could actually start contributing and maintaining that library. Turns out this other user didn't have very good intentions, and he actually pushed out malware through this. And this story blew up. A lot of people were like, oh my God, how is this possible? And this is ridiculous, and all of that. And honestly, if you're using software to build your applications and you're relying on volunteer-based products, then I don't think you should be pissed at those people for doing the best that they can with their time. They're all volunteers. This guy built that library in his free time and was maintaining that in his free time. So don't blame developers for that. That's one thing. But this shows a bigger problem, and this shows that this ecosystem is very brittle. And it shows that people actually actively try to abuse that. And it's getting worse. So you have these attacks are rather silly. They're very basic. They're very easy to detect often. And they just try to hit as many applications as possible, probably stealing some rather less useful information. But recently, and this is from about a month ago, well, a month and a half ago, we've seen other cases where people are starting to launch targeted attacks against specific applications. And here's a story that should really scare the hell out of you. This is a story from an application called the Agama wallet. It's a cryptocurrency wallet where you can keep track of your cryptocurrencies, which might go on a crazy ride. I honestly don't follow it that closely, but if you're doing that, you actually know what I'm talking about. And what happened here is that a hacker, this was an open source application hosted on GitHub, and we could see it, and the hacker, in this case, acting as a good guy, suggested to add some features. Like, hey, wouldn't it be cool, it's an Electron app, it's running on a desktop, wouldn't it be cool if we had like native notifications? If you could integrate into macOS or Windows or whatever and show some actual notifications instead of some weird web-based thing. And the maintainers, the builders of the application were like, yeah, that's actually pretty awesome. So why don't you build that and send us a pull request? And the attacker was like, cool, yeah, I'm going to do that. And he came back a couple of days later, like a week and a half later. He published a package on NPM called Electron Notify Native that actually did exactly that. It essentially used the native OS hooks to show some notifications. Totally legit code, everybody really happy. He pushed out that pull request, and they actually integrated that into the application, March 8th. This is 2 weeks after the hacker proposed to work on that. Here's a pull request. That's definitely a quick turnaround time, and everybody's really happy. Seemed to work, totally legit. Nothing malicious has happened yet. This is a legitimate open source contribution by someone on the internet. And then this package, Electron Notify Native, which is maintained by the attacker in this case, turns malicious. And all of a sudden, poof, it contains a piece of malicious code now, which is problematic, but that's how things work. And then after a while, the application pushes out a new version, it updates their dependencies, they pull in the new version of Electron Notify Native, and they're now running malware on the actual application. And that malware was stealing the seeds to access your cryptocurrency wallet and sending them to a public server somewhere so they can be collected. And the attacker was just sitting and waiting until he got as many links to as many wallets as possible. In the meantime, the NPM security team actually noticed that something weird was going on. So they noticed that there was this malicious update of the Electron Notify Native package, and they were like, uh-oh, this is a problem. And they notified the company about that, like say, like, hey, there's something weird going on, and they looked into it, and essentially they kind of panicked because they realized what the malware was doing. They realized that somebody was actively stealing access to people's wallets and was about to steal all of that money. And that's when they said, like, you know what? Let's steal it ourselves. And they actually exploited the vulnerability the attacker created to steal everybody's money and put it in a safe location. So essentially, they stole from themselves, they put it away, and they contacted the users to say, like, yeah, we kind of had this problem. We were about to get robbed, essentially, but we took care of it, we fixed it, and we have your money in a safe location. You can reclaim your wallet using this and this procedure, and off you go. But this shows a very dangerous pattern. This shows that essentially people are targeting real applications with benign-looking code, and then afterwards they turn one of the dependencies malicious, which is going to be really hard to detect. And in this attack, it was like a one-step. This was a direct dependency of the code now. But what if the attacker would have created a tree with like 3 or 4 different steps before the malicious package would have been discovered. That would have been a major problem. And as application developers, this is really hard to defend against because there's no checks on the whole system. There's no way to know when a package turns malicious unless somebody actually looks at it and decides like, whoa, what the hell is this? Which in this case was the NPM security team. So they do scan a lot of packages and they do try to detect as many of these problems as they can. And in this case, they actually did found the problem. And the moment it's found, you know about it, because the moment these things are found, they are typically published and reported. So you have tools like GitHub's integrated dependency graph that can actually make this work. So GitHub can actually scan your packages and tell you like, hey, you have a vulnerability in your code. And OWASP, I mentioned OWASP in the beginning, from the top 10, OWASP has a similar tool called Dependency Check, which supports a couple of other languages which can do very similar things. And I see Sam is kind of getting anxious now, but don't worry, because Nick, the host of this very nice live session, actually has a very great tool that does things like that as well. And they integrate very nicely with the Git repo. I'm actually using their tool myself, and I'm definitely like that process as well. But the essence is, the only way we can defend against these kind of things is by scanning for known vulnerabilities. Things other people have discovered and have reported. Yes, they're in a database and they can be discovered, and you can get notifications like, hey, you actually have a vulnerability, you probably want to fix your application. But for unknown vulnerabilities at the moment, there's no good solution yet. And this is one of the drawbacks of what we're doing today, and definitely something that will become more and more important in the next 6 to 12 months. That brings me to this takeaway. So if you're dealing, for me, this is vulnerability number 1, because so many people are unaware of this happening, and you need to have the proper processes in place. If you're including external JavaScript files, this means sub-resource integrity is going to save your ass one day. So please use and deploy it. You need to set up dependency checking for your applications, for all of them. You need to get mails immediately as a vulnerability is discovered, and they also send you like weekly reminder mails if you don't fix it immediately, and they keep harassing you essentially until you do, which is actually what you want. And then finally, you need to have cycles to actually work on this. You need to be able to update your applications immediately. And many companies are getting more and more strict in that. So many companies have internal policies that states like, hey, we need to be able to update applications within 24 hours in case some of these things gets public, because this is really, really important. And honestly, doing so in 24 hours is not something you easily get done. This is something you have to plan for upfront. You have to decide who's responsible for doing that and how you are going to address these things in practice. But you need to start worrying about that, because these attacks are getting more and more frequent, and protecting against them is absolutely, absolutely necessary. And that brings me back to the slide I showed you in the beginning. So using components with known vulnerabilities is definitely number 1, if you ask me. Things like authentication are also very, very important. This is an insanely complex topic because there's so many options, so many trade-offs, and especially if you pull in OAuth or OIDC, things get really complex really quickly. Cross-site scripting in Angular is actually pretty good because Angular has you covered. It's a very important problem. You still need to know about the things not to do. And if you're using something else than Angular and listening in, those frameworks require a bit more effort for the sanitization part, but they have the encoding part. Usually they have that down. Access control, that's listed here. It's not a front-end responsibility. You cannot do that on a front-end at all, but it's about, it includes how to manage sessions or state or how you want to handle that. So that definitely plays a role. Again, very complicated if you start doing things with jobs, which might not work in ways you anticipate their work. And then finally, sensitive data exposure. We talked about HTTPS, which is one. If you're storing data on the client, definitely think about the sensitivity of that data, think about encrypting that data if necessary, and things like that. And the other ones are relevant, but more backend responsibilities than front-end responsibilities, hence the reordering here. All right, so let me wrap this up by pointing you to a resource. I've built a security cheat sheet for Angular specifically. So Angular and the OWASP top 10 is in there with some details, some things to look out for your applications, things to avoid. There's a cheat sheet on JSON Web Tokens as well. If you're working with that, you should be aware of those. And there's a cheat sheet on how to keep data in the browser, some patterns you can use. These are free. There's a sign-up form so you can get updates of the cheat sheets, which I push out every few months. But of course, there's also a link beneath the sign up button. If you don't want to share your email address, that's totally fine. Just grab the cheat sheet and just come check every couple of months for an update, so you always have the latest version. And with that, I'm actually gonna shut up now for a few seconds. So you can follow me on Twitter. I do tweet about security, so that's going to be really useful. There's a lot of useful resources that pass by, some new attacks, some news that's going on. Feel free to connect with me on LinkedIn or reach out to email if you have any questions. If you're looking for training specifically on modern applications, feel free to reach out to me as well. And if you have any questions, I think we have some time to answer those now. Right, Sam?
So yes, we do.
All right.
So we've had quite a little bit of chatter on the Slack channel today, and some questions being asked. I think some of them you covered though as you were going through. And let's see, we've got one about your name. How often do you get called Felipe instead of Philippe? And I mean, I did that on the way in, so at least
yes, the name is actually based on the French. It's a French name of Philippe. So yeah, I'm totally used to suffering with that.
I can only imagine. So one of the questions that came in was actually about sort of JavaScript libraries in general, and it was from a gentleman by the name of Mango, and he would like to know if Angular, React, or any other JavaScript framework, which one is the safer in terms of sort of vulnerabilities and security mistakes within?
That's actually a pretty good question. Honestly, I'm not really aware of any major security holes in any of these frameworks. So they're built by good people, by good teams. They're very actively maintained, and there hasn't been like, oh my god, the house is on fire case that hasn't happened yet. So honestly, I think that's pretty good. I personally like Angular the best, not necessarily because they have less vulnerabilities, but because they do more out of the box and they actually handle more security. So they're very active in that. But other than that, there haven't been major vulnerabilities in the libraries itself. There has been one case in a React an addition to React, the Redux library had a vulnerable code snippet on their website for a while, which actually had a cross-site scripting vulnerability. That did happen, but that got fixed as well, and people were notified about that as well.
That's really good. One of the other questions was actually around, do you remember or know of any security vulnerabilities in Angular? So that answers that question as well.
Yeah, exactly. So in Angular 1, they tried to add additional security features, which turned out to be very hard to get right. So they took that out again, but I wouldn't count it as a vulnerability. So no, today these frameworks are actually pretty good.
Amazing. And then we have one from Kelly, and she'd like to know if you have any good security tool recommendations for capturing sort of low-hanging fruit with modern JavaScript applications.
Oof, that's a good question. So honestly, I don't have too much experience with the commercial tools, but based on some Twitter discussions from a couple of months ago, it seems that most commercial code scanning tools or something like that are not really that great at detecting problems in these JavaScript applications. They might be able to find some of the cross-site scripting vulnerabilities because they are fairly straightforward to detect in code. And you also have some linting rules available which you can use to to easily scan your code for occurrences of these dangerous patterns. But the problem with these things is determining whether it's a problem or not, because you can easily spot the bypass security trust HTML function, but it depends on what you feed in there, whether it's a problem or not. And that's, I guess, something that many tools struggle with. But I definitely hope this will improve in the coming. Okay, that's actually a very interesting thing. Yes, there are a couple of things you need to know about Angular 1. First of all, data binding with the curly braces is still covered. So they have that fully covered. It will automatically apply this encoding unless you turn it off. So in Angular 2, there's no way to turn it off. In Angular 1, there was a way to disable SCE, it's called, strict contextual escaping. So you need to make sure you do not turn it off. That's number one. Number two is sanitization is not applied automatically. If you try to bind to inner HTML with ng-bind HTML, that is, it will throw an error. And the most important thing you need to realize to fix that error is you have to include the sanitizer. Every other fix is bogus. You can find Stack Overflow posts that tell you to use this trust as HTML function, which simply outputs anything you give it, including malicious code. So you can never ever use that. But if you add the ng sanitize to your module imports, you're also covered, because that will enable the sanitizer, and from that point on, Angular will sanitize for you and will do that correctly. The third thing we need to be worried about is template injection, because Angular 1 is not pre-compiled. And because of that, somebody might be able to inject template code before Angular runs. So some people combine Angular with ASP.NET, for example, and if your ASP.NET page outputs something untrusted, which can include Angular code, which is totally safe as far as the server is concerned, but once Angular sees it when it's bootstrapping, it's like, ooh, Angular code, that's for me. And it has the ability to execute that code. But if you're using Angular 1 in a static way, completely static, and you do not use the order by filter for tables, then you're also not going to suffer from template injection as well. But these things are actually well documented. It's one of these things I talked about. They try to prevent template injection attacks in Angular, but that turned out to be way too complex, and they decided in Angular 1.6 to not offer that anymore because it was a nightmare and it could be bypassed. So if you Google for Angular expression sandbox, you're going to find definitely some articles that cover that. And if you otherwise shoot me a tweet, and I'll definitely send you some links you can read up on these things about.
Perfect. And we can also put some of those links in the show notes for everyone. I think that was all the questions we had. There is someone typing. Let's see what's coming through. But we'll get those. Yeah, I think those are just lots of thank yous. So thank you so much. I hope everyone enjoyed that, and thank you again, Philip, for being involved. We hope it's not the last time we have you on the Secure Developer. Hopefully we have you again soon, but I hope everyone enjoyed that. As I mentioned before, if you would like to rewatch the session or anything like that, you can find the recorded version on thesecuredeveloper.com. And please, as I said, jump into the Slack channel and keep those questions coming in, and we'll get them answered if you haven't watched this live, or if it's more questions will come to you. Our next session will be in 2 weeks' time on the 1st of August, and we're going to be talking about implementing DevSecOps in Azure with Victoria. So please, again, jump to the website, get your tickets for that. And in the meantime, I hope you enjoyed it. We do have, if you aren't aware, a podcast that comes out every 2 weeks, and there's some great sessions on that. We've had some great hosts, so do give it a listen. And thanks again to the team at Sneak for supporting and powering this community. It really is appreciated. So I hope everyone has a great day wherever you are in the world, and we'll see you again. And again, thank you again, Philip, for joining us.
It was my pleasure. Thanks for having me.
No problem.
Bye-bye.